Hi students, I am your Nagini ma'am, chemistry mentor. In this section, I am giving an excellent trick to convert Wedge-Dash formulas into Fischer projection formulas, organic chemistry students. In case of one chiral carbon, I am discussing. This is the Wedge-Dash formula. This is the Fischer projection formula, students. In the Wedge-Dash formula, these two are thin lines. This is the dashed line. This is the solid line, students. Solid line or wedge line. So, wedge or solid line. So what it indicates, students, towards the viewer. Okay, na? Towards the viewer. This is the dashed line. It is away from the viewer. These two thin lines always on the plane. Clear? In the Wedge-Dash formula, students, these two are thin lines. They are on the plane. This is the dashed line. The dashed line, it indicates away from the viewer. This is a wedge line or solid line. Okay, it is towards the viewer, students. Towards the viewer. Clear? So this is the Wedge-Dash formula. Now coming to here, Fischer projection formula. Fischer projection formula. That means the same structure we can write into Fischer. Understanding? So same structure only in different forms we are writing. Okay, now one is Wedge-Dash, another one Fischer. Why we are calling this is Wedge-Dash means here wedge line, this is the dash line. Both are there here. That's why we are calling as Wedge-Dash formula. This is the Fischer projection formula, students. Okay, na? Here horizontal line, vertical line. These two bonds here on the horizontal line, this horizontal line, it is always towards the viewer, students. This is the vertical line, it is away from the viewer. Clear? Away from the viewer. So, how to convert Wedge-Dash formula into Fischer projection formula, students? Just you have to follow this trick, students. Very easy trick. You can easily answer any type of question. Okay, now in this conversion, students, Wedge-Dash formula into Fischer. Very simple trick. See here. This is the, suppose here viewer there. Okay, observer. How it is, students, these thin lines, how it is to the viewer? It is left hand side, kada? If suppose here viewer there, how it is these two thin lines? Right side. Understanding? To the viewer, this is left hand side, this is right hand side. Left, right, left, right. Okay. Now see here I am writing separately. This is left hand side, this is right hand side. Thin line, thin lines. This is left, this is right hand side to the viewer. Clear? Right hand side. Then in the Fischer projection formula, how to write? If suppose in the Wedge-Dash formula, okay, the two thin lines are how they are, students? Left hand side there means to the viewer. Okay, left hand side. Then the two here thin lines, the two thin lines, just first you have to write on the vertical line, students. That means here whatever the thin lines are there, you should write on the vertical line first. Next one, what you have to do, see here in this example, these two thin lines I am writing on the vertical line, AB. This one completed. Whatever the thin lines are there, that you should write on the vertical line. Right here A, here B, A, B, vertical line you should write. Now see here to the viewer, how it is left hand side. To the viewer, this is left hand side there. Then what you have to do, solid line you should write left. On the horizontal line, solid line you should write left, students. Okay, when you have to follow this one, to the viewer, if the thin lines are left, thin line is left, the solid line should be left. If the thin line is right hand side to the viewer, the solid line is always right. Understanding? If the, see here, thin lines are left, this is left, this is right. So left there means the solid line left, right there means solid line right. Okay, left, solid line left. Where should write left? On the horizontal line, left side. This is left, right. Left side you should write this solid line group. Clear? So two thin lines right on the vertical line AB. This solid line where should write? Left hand side, because it is left. Understanding? Left, solid line left. So solid line where should write? Left on the horizontal line. Clear? Horizontal line. So right here D, this is dashed line, other one group you have to write opposite side. That's it. Very easy. If suppose Wedge-Dash in the Wedge-Dash formula, the thin lines are like this, means it is right. Just you remember students, it is left, this is right. Left there means left to right, first you write on the vertical line. It is left there means solid line you have to write left. Okay, here solid line right, left to left, right to right, that's it. Understanding? Here see, this is left. Okay, thin lines are left, then solid line left, thin lines are right, then solid line right, left to right to right, that's it. Very easy, very easy. See here. Okay, so this compound understood. The first what you have to do, AB groups. So these two are thin lines, so you have to write on the vertical line. Next, what this is how it is students, left hand side. It is left dash this one. This is a solid line. Solid line we should write left on the horizontal line. Another group, see here. Okay, now see here examples we will discuss students. Take this example. See here. Very easy. See here how it is students. It is left only na. It is left. It is left. It is also left. It is also left. Very easy. See here left hand side is there. So what you have to do, these two thin lines, first you have to write on the vertical line. These two thin lines you have to write it as vertical line. Okay, this is horizontal line. Understanding? This is which formula students? Wedge-Dash formula. We are converting into Fischer structure. Understanding? We are converting into Fischer. So these two thin lines you have to write on the vertical line. So CHO here students, CH to OH. Okay. Okay. First you should write the two thin lines on the vertical line, and the two thin lines how they are students, left hand side there. Left hand side there means solid line left. This is left, solid line left on the horizontal line. So what is the solid line group? OH. Here left side you should write. Clear? It is left, then solid line should be left. Left, right. Other one arrow, hydrogen. You should write on the opposite side. Clear? Clear? Very easy. See here next compound. See Nana. See here next compound. These two thin lines, first Fischer structure, draw one horizontal line, but vertical line you have to take it. Now see here, these two thin lines you have to write on the vertical line. So CHO, CH3, this one completed. It is which one students? Left hand side to the viewer. Here viewer there. How it is students? It is left hand side. Left side there means solid line also. You should write left side on the horizontal line. So left side horizontal line, OH group you have to write here. Other one group you have to write opposite side. Very easy. Understood? So this is which formula students? Wedge-Dash formula. This is which formula students? Fischer formula. Okay. Very easy. See here. In this structure, how it is students? Thin line. First you draw the Fischer structure. How to draw the Fischer structure? One vertical line, one horizontal line you have to take it. Now these two thin lines you have to write on the vertical line, COOH, CH3. Clear? These two groups you have to write on the vertical line students. So how it is students? It is left hand side. Understanding? Clear students? So these two thin lines you have to write on the vertical line, COOH, CH3. Now see here how it is students. This is left hand side to the viewer. So this is two thin lines are left hand side. Left hand side there means this solid line. This is the solid line. It should be on the left side. Understanding? Left side on the horizontal line. So which group students? Horizontal. This is left side group, NH2 group. Right here NH2. Other one you have to write right hand side. Very easy. Now see here, these two are thin lines. Thin lines you should write on the first Fischer structure. You take Fischer structure, horizontal line, one vertical. Okay, one horizontal, one vertical line. Okay, on the vertical line these two thin line groups you have to write CH2OH, CH3, and this is towards the to the viewer. This is left hand side. That's why that solid line group you have to write left. This is left. This is left. Clear? So you have to write left chlorine on the horizontal line, left hand side. Other one group you have to write right hand side students. Very easy. Understood? Now see here this structure, this one. Here how it is, students? These two are thin lines. Okay, thin lines. This is dashed line, this is solid line. These two thin lines, how to write, students? How to write this one? Two thin lines, so you have to write on the vertical line. Clear? So first Fischer structure, one horizontal line, one vertical line. So on the vertical line you have to write here whatever the groups are there on the thin lines. You just write on the vertical line CH3COOH. Clear up? CH3COH. How it is there, students? To the viewer, suppose here viewer there, it is right hand side. Clear up? So this is right hand side, that's why dash line, this is dash line, this is solid line. Okay, this is right hand side. Understanding? Okay, now towards the viewer, the two thin lines are right hand side. Okay, now right side, then the solid line you should write right side on the horizontal line according to the trick. Clear? If it is right side or right side solid line, you should write right. Understanding? See here, this is right. So that's a solid line. You should write right side on the horizontal line. So that means this group you have to write horizontal line right hand side. This is R, this is R. Another group you should write on the left hand side. Very easy. But see here, just little you have to rotate this, you have to just little change in a structure, because COOH is the first priority functional group. It should be always at the top of the vertical line, students. Understanding? At the top. So that's why what I am doing, 180 degrees. Okay, just rotate this compound. Then COOH, okay, now whenever rotating 180 degrees, the COOH group will come to here, CH3 will come to here. Understanding? Rotating 180 degrees. Then what you will get, students? This is the vertical line, this is the horizontal line. The COOH group will come to here and CH3 group will come to here. Understanding? Then H2, NH2. NH2 will come to here and here hydrogen changes to here. Just they changes their places. Okay, na? Whenever this compound 180 degrees rotate, the COOH group coming to here, CH3 will come to here, NH2 here, hydrogen here. Are you clear? Understood? Very easy, Nana. Okay, COOH, CH3. So this is the correct structure. This is also okay, but you have to remember, students, first priority functional groups always on the top, Nana. Okay, na? On vertical line. Clear? Like this you have to change it. Little change will be there here. Okay. Thank you, students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, Lana. Thank you, students.